Alright guys, today we're going to be looking at one more problem that we can solve using binary search, and I would say once we are done understanding this problem we should be confident enough in the binary search pattern, and I can assure you that we will be able to solve any similar pattern related problems, and we can conclude our binary search pattern after all. So let's dive right in. The problem statement here says that given a list of integers and number of readers where each integer represents the time it takes to read an article, return the minimum amount of time it would take to read all the articles. So in short, we're given a list of positive integers and each integer represents the time it takes to read that article, and then we are also given a positive integer representing the number of readers, and we need to determine the minimum amount of time it would take for these many readers to finish reading all of these articles. Alright, let's see how we can walk through this example to understand it better. So the first article takes about 7 to read. The second article takes about 2 minutes / days or years. We don't know the unit of time here, but we would say let's take into account the minutes as our standard time unit. So the first article takes 7 minutes to read, the second article takes 2 minutes to read, the third article takes 5 minutes to read, and so on. And we have 2 readers. There's one more constraint given to us in the problem statement, and the constraint is you can only assign the articles in order from left to right. And that will mean we can, once we start assigning the articles from the left, we cannot skip the articles. We have to assign it to the current reader and then move on to the next reader. So with that rule in mind, I would say that I want to assign, so reader 1, I would want to assign reader 1 articles 1 to 3. So the article 1 takes 7 minutes to read, article 2 takes 2 minutes to read, article 3 takes 5 minutes to read from the list given to us. And I have assigned these 3 articles to reader 1, and the remaining articles obviously will go to reader 2 because that's the only reader left for us to assign articles to. So we would say 10 and 8. Right? So fourth article takes 10 minutes to read, the fifth article and the last article takes 8 minutes to read. So reader 2 gets to read the last 2 articles, reader 1 gets to read the first 3 articles. Now, based on our constraint, we cannot skip and say that I want to assign the last article to the first reader and then the third article to the second reader. Since we're going from left to right, we have to first finish assigning articles to reader 1 and then move on to assigning articles to reader 2. And then we want to see how much time both of these readers take to finish reading it. Let's see the minutes reader 1 takes to finish reading all of the articles. So it would be 7 minutes plus 2 minutes plus 5 minutes. That is 14 minutes. Alright. So it would be 14 minutes. Right? Now let's see what time concurrently reader 2 is also trying to read the articles assigned to him. So the amount of time it takes for reader 2 is 18. Now as you can see, this is kind of the optimal split between reader 1 and reader 2. What if I assign the first 2 articles to reader 1 and the remaining articles to reader 2? That would increase this 18 to a bigger number, and we don't want that. Although it will shrink the reader 1's total time taken to finish reading all the articles, it would increase the higher number for reader 2, and we want to minimize it. So looking at the problem again, we have this minimum keyword in the problem statement, and so with that we should take a hint and say that this is a minimization problem. So in a minimization problem, we are always looking to shrink our final output, and in this case, if I change the assignment, I am not achieving what I'm looking for, and that is to minimize the total amount of time taken to read through all of these articles. So I'll go back to my original assignments. I'll say I'll assign the first 3 articles to reader 1 and the last 2 articles to reader 2. It would take 14 and 18 minutes respectively, so assuming they both start reading at the same time, the first one would finish in 14 minutes, the second one would take 4 additional minutes, and finish reading the articles in 18 minutes. So the total time taken to finish reading all of these, it would be the max of total time taken by reader 1 and reader 2, which would be 18. And so our output is 18. Now, how do we ensure that this is the minimum time it takes? Well, you can try rearranging, or you can try reassigning reader 1 and reader 2 the respective articles in order, though, to respect the constraint given to us in the problem statement, and see if we can shrink it any further. Well, we just tried to do it and we weren't able to. There's only one way to change the order, and that is to say the first 2 articles to reader 1, but then as soon as we start adding up more articles for reader 2, we are incrementing this number, and we don't want that. We want to minimize this bigger number. All right, so right now, initially, we don't have a number in mind, right? So the output could be some random amount of time it takes for our readers to complete reading the article. So let's just go with that assumption and say that it would take some random amount of time for us to read through all the articles, right? So we could say, assume we take some 100,000 minutes to go through all the articles. And then we try to shrink it. So let's assume that the time given to us is 100,000 and or maybe a million in this case, and then we want to go through our articles and see if we are able to assign it. So let's say we have a million here, and then we want to assign it to our readers, right? And the only way we'll be able to do it is go through this list given to us from left to right, and then assigning the articles to readers in order. And let's say we assign 7 to reader 1, 2 to reader 2, and so on. We would end up taking far less time than the time that we had originally assumed. So it's time to shrink it. So let's shrink it by, let's say, half, right? And then we read some 500,000 number, and then assuming that we have 500,000 minutes to finish reading all these articles, we start assigning these articles to reader 1 and reader 2 in order, and we realize that we are still able to read through the articles in far less time. And so again we shrink it by half, and so on. So we'll eventually get to a point where we won't be able to where our number will be so small that we won't be able to go through all of these articles, and so we'll have to increment it by half every time, and then we have to kind of multiply it by half every time, and then we eventually get to a point where we get our minimum time required. So you can see the pattern here. The pattern is, once we have identified a search space, and that is something 0 minutes to a million minutes, we are trying to find that optimum result in the search space. And since we are dividing it by half, I would say this is kind of a binary search. So even though our input array is not sorted, our search space is still assumed to be sorted. So let's quickly write our class for this problem. I would say I want to create a class read articles, right? And then in that class I want to initialize a constructor, and I would say this constructor would take in the array, right? So times it takes, and then readers, and then I would say this dot times is times. This is the member variable of read articles. Readers would be initialized to the number of readers that we already have. All right, and now I can create a function called article minimum time to read all, and called by the external entity, and we would kind of do our binary search kind of thing here. So let's first define a search space. As we try to walk through our example here, we said that we want some right bound which would be a huge number, and then the left bound would be 0 minutes, right? So let's just do that. Left would be 0, and then the right would be some huge number. Let's say that number, for now, you can choose to use any number. I'm just using this arbitrary huge number. And then again, the first thing that we did was to shrink it by half and see if we're able to finish reading all those articles in that stipulated time. So while left is less than equal to right, that's our simple binary search pattern. We try to find the minimum time, right? So it's a time to the total time, right? Which would nothing be math dot trunk. We'll get to discuss this in a moment. We'll say left plus right over 2. Alright, left plus right over 2 is going to give us a decimal, a floating point value, and the math.trunk is just going to take the integer part of it. And now that we have decided upon our total time, let's try to see if we can go through the given array, which is times, using all of these readers, and let's see if we're able to make it through the end. So let's create a check function, and we can assume that this function is private and it's only being called by the minimum time to read all. And now we want to say, we want to see if we are able to get through the array. So I'm setting my total to 0, and then let's also create a split, which let's initialize to 0 for a moment. And now I want to go through all of the times. I would say times, my bad, times, this dot times dot for each. So for each, we can just have, so assuming times is going to be an array, we can just use for each for it, and each time we're going to get an element, and that element is nothing but time. We can say that if that time is greater than the time given to us, so we need a time, right? So when we say total time, so if an individual article's time is greater than the total time that we have decided for ourselves, then it's totally not possible to get through the array, so we just return false. So we expect this function to return true or false. True if we are able to read all the articles within the total time, let's return false. That is the main objective of this function check. So if the time of any individual article in the times array is greater than the total time that we have decided for ourselves, then we know that the answer is going to be false, right? So we just return false and we do nothing. If that's not the case, we need to continue our iteration and say if total, if our time plus the total so far, right, is greater than the total time that we have decided for ourselves, then we know for sure that this total so far needs to be reset, and the split, which is the total, which is a variable, keep track of number of readers, and then we just say split the list from this point forward and add 1 to it. So far we have 2 splits, 3 splits, and it'll keep incrementing. So we have the total incremented to the time. And once we have that, we're going to discuss this loop in a moment. So once we have that, once we are done iterating through the list, say if total not equal to 0, then we know that we need to increment split one last time and then return if the split is less than or equal to the number of readers given to us. Okay, looks good. Now let's see what the intuition behind this loop was. We said this is the reader that I want. So to make it easier to understand, let's rename this symbol and say readers used so far. Okay, so we say that this is the total time that we have decided for ourselves, and we need to check if we are able to read through all the articles using the readers using the total number of readers given to us within this total time, right? And then we can also rename this test symbol to improve to improve clarity. We could say time so far, right? Initially we say time so far is 0, readers used so far is 0, and we start iterating through the list, iterating through the array of time articles given to us, and each time we check if the time is greater than the total time that we have decided for ourselves. If it is, then it's right out of the window and we just return false and move forward. If that's not the case, then we need to check if time plus time so far is greater than the total time, which means the time to read this current article plus the time we have already consumed reading the previous articles is greater than the total time which we have decided for ourselves. Then we need to reset everything and we need to start using the second reader, right? First reader has exhausted all the time, so we start assigning articles to the second reader. So we increment the readers used so far plus 1, and then time so far should be reset to 0, and then this reader, starting at this reader, we need to increment the time so far. So we say time so far equal to the time required to read this current article, and at the very end we need to check if we needed an extra reader at the end, right? So if time so far is not equal to 0, then we are left with one last reader that we had to use, and then eventually we check if the number of readers used is less than the desired readers given to us. Alright, and it returns a boolean value and we get back. So let's see, we were at minimum time to read all, and here we had kind of decided the total time required for us, and now we just want to check, right? If let's pass in this total time to our check function and see if we are able to cover all the articles within the stipulated time. If we are able to do so, then we know that there is a smaller amount of time that we can use to go through it. So we shrink our time. In order to shrink our time, we just say that our write is nothing but total time minus 1. Now if we are not able to make it in time, then we need to increment our time or increase our time. So we say our left equals total time plus 1. Alright, and at the end of the loop, we just want to say return write plus 1. Because we started write at some huge number, we would end up utilizing the total time it takes for us to read through it, and then since we are always incrementing write with total time minus 1, we need to add plus 1 while returning it as our final answer. And now that's this done, let's try to run it. Okay, so let's try to run it. I usually use this online interface to run my code. It just uses Node.js behind the scenes. So let's just call our function. We say console.log. Oh, well, before that, let's just create our read article. So let's say read article object is going to be new. My bad. It's always good convention to have the class name start with the capital. And we'd say new read article, and then let's pass in the times. I will copy the example in a second, and then the number of readers given to us, and the number of readers and the time that's given to us was 2, and the number of the list was this, and the number of readers was 2. Okay, now that we have initialized that, let's call it and say console.log read article dot, let's call minimum time to read all. Let's see if it works. Alright, we got 18 as an answer right here. Well, this is what we were expecting, right? And so this was just a basic example of how we can use the intuition behind binary search to solve problems where we have a search space defined and we are looking to find an arbitrary number, and every time we want to shrink our search space by half, right? And again, the time complexity here is going to be something similar to what we saw last time, and that would be, let's kind of mention it here, the time complexity would be big O of n log n, right? Where n is the number of, or we could say length of the times a day across. Alright guys, hope you were able to understand this, and we'll see you in the next pattern video, and until then, happy coding.